Hey everyone, so today we'll be discussing problem C, random events of Codeforces round 689 Div-2. So let's jump to the whiteboard. So the problem says that you're given a permutation of length n and there are m experiments to be done on this permutation. Now each experiment is of the type RIPI, which means that elements in the range 1 to R1 are to be sorted in an ascending order with the probability Pi. Now you need to tell, after all the m experiments are done, what is the probability that all the elements in the array are sorted. So let's take an example. Let's say that we had a permutation of length 5, that was 4, 2, 1, 3 and 5, and there were 3 experiments to be done, which means that the first 3 elements have to be sorted with the probability 0.8. Then the first 4 elements have to be sorted with the probability 0.6. So we can say that these are to be sorted with the probability 0.6, and then all the 5 elements are to be sorted with the probability 0.3. Now let's try to figure out what all experiments are useful to us in sorting the array and what aren't. So if we look at this permutation, we can see that this 5 is already at its place and this 3 is not at its place. Therefore, we can say that any experiment which sorts less than the first 4 elements is of no use to us, because if we see, let's say we took the first experiment and it sorts the first 3 elements, we can say that the array is still not sorted and therefore this experiment is of no use. Whereas if we look at the first experiment and the third experiment, we can say that this experiment will completely sort the array and this experiment will also completely sort the array. And with this we can say that this experiment is of no use and we only need to consider this experiment and this experiment to sort the array. Now let's look into these two experiments. So let's say this was the complete array. Now we have a 0.6 probability that this experiment will completely sort the array. So we can say that for sorting the array we have a probability of 0.6, and if we do not sort this array we have a probability of 0.4. Now let's see what happens when this experiment comes. When this experiments come, we have a 0.3 probability that it will sort the array. So again, for sorting we have a probability of 0.3, and for not sorting we have a probability of 0.7. And similarly in this case, for sorting the array we have a probability of 0.3, and for not sorting the array we have a probability of 0.7. Now let's look into these paths. So if we look at this path, we can say that this path actually ends up making the array completely sorted. So we need to take this path, then again the same for this path as well, because we sorted it here, therefore this path is also to be considered. Then if we come on to this path, we can see that the second experiment actually sorted the array, therefore we need to take this path as well. And now if we look at this last path, we can say that there was no experiment which actually sorted the array, therefore we don't have to take this experiment. Now let's try to look into the probability with which each path will occur. So we can say that this path will occur with the probability of 0.6 into 0.3, therefore the probability is 0.18. Then this path will occur with a probability of 0.6 into 0.7, that is 0.42, and this path will occur with a probability of 0.12. And if we sum these values, we get 0.18 plus 0.42 plus 0.12, which actually makes 0.72, which is the required answer. Now let's try to recall what all we did in this problem. So basically we first found out the first index from the last which was not already sorted, and then we took only those experiments whose Ri was greater than or equal to this index. After doing that, we found out all the paths and then added up the probabilities of these paths happening in which we at least sorted once. Now if you see, we actually do not have to complete a path if we have already sorted once in that path. For example, if we see in this one, we actually sorted it at this step, therefore we do not really have to consider both these options, because eventually 0.18 and 0.42 already adds up to 0.6, therefore we can directly add 0.6 and 0.12 and the answer would be 0.72.
So this is the code. I'll have the link to my submission in the description below. If you still have any doubts in the problem, feel free to reach out to me and like this video and subscribe to the channel if you want to see more of such editorial videos.